to be introduced by the chairman. The panelists are going to be introduced by the chairman of the sessions, and it's my great pleasure to introduce Mr. Julio de Larosa of Acciona Agua to chair this panel and introduce his own panelists. Julio is a seasoned and a very, very experienced person in our industry, has decades of experience, and have been serving with Acciona for a long time. Acciona is a major player in our industry. So please welcome Julio de Larosa to this panel.
Thank you very much, Corrado, for your kind words. Not that much. Thank you very much for the invitation.
Julio.
Thank you. Thank you very much. And thank you very much for all the audience to attend this panel. We are going to try to go deeper in the advanced materials and membrane desalination. So for this, I'm going to introduce you the panelists we have with us today. First of all, we have Rosario Blasetti, is engineer manager from SWPC. Rosario. Thank you. In second position, we have Anthony Ahmad from Entegris, and is the president for EMEA region. We welcome him to the stage. Anthony, nice to meet you. And last but not least, we have Mr. John Hong from TACA. John. Thank you very much for joining us. Welcome. So here we are. We are ready to go. Well, you know, in all the desalination plants, the membranes used to be the, let's say, the core of the plants, and is the critical, let's say, element, just not only for the production of water, but as well for the energy consumed during the production. This is why it's very critical to protect the membranes, and in this regards, I think that today Anthony Entegris is doing a huge effort. So can you tell us what Entegris is doing, can provide the add value to protect the core of the desalination plant, that is the membranes, and the benefit is that we can get from that protection?
Absolutely. Thank you very much for the question, Julio. So indeed, Entegris is working on protecting reverse osmosis membranes that are very important and very costly products in the manufacturing operation. Entegris has 60 years of experience in filtration and purification, and we have our experience comes from very demanding industry like semiconductors, where purity is very important. And when we talk about water treatment, what we have transferred to water treatment is that expertise in protecting reverse osmosis with our filters. So it's cartridge filters and filter elements. We do that in polymers. The housings are in GRP. That's one thing we do. It's really bringing purity to the operation. And the other aspect we do is we make particle measurements, inline particle measurements, on-time particle measurements. So if you want to think it in a very broader way, if we have a tagline, it's like see it, control it. See the contamination coming, and then control it with the right polymers. And I say and insist on the right polymers. You need to have the right structure. You need to have the right density in the filter you're going to use to protect the reverse osmosis. And the idea is basically to have the right filters with the right pressure drop. And you asked what's the benefits we can bring. If you have the right membrane, well, the right filter to protect the reverse osmosis membrane, you can play with the structure of the cartridge, and with a lower delta P, you have the same retention. Basically, if you have a lower delta P, you will need less energy to push the water through the cartridge filters. So that's one very important benefits we bring to the operations. And on top of it, with the particle monitoring online in time, we are all very hungry of data collection. And with inline monitoring of particles, you can collect on time the data and the particles you have, so you can feed your master process element in the operation, whatever it is, to understand what's happening online.
Okay, thank you very much, Anthony. That's very true. It's very important to control the delta P at the Cartier filters element, to monitor, to get data, and to transform this data into information, because it's not only to get the data, but how you treat the information you collect. In this sense, being a target that we have to develop new materials for the desalination, Rosario, in this regard, at the time of facing the development of new material, which are the more critical factors to be considered on this stage?
Yeah, improving membrane technologies and membrane material to making are the key to making the membrane application more efficient, more cost effective, and more sustainable. The key factors for developing new material are the permeability and selectivity. So if the membranes are too restrictive, the water flow slow down and the energy cost increase. Vice versa, if the membranes allows more through the water quality, the final water quality suffers. So the challenge is to balance these two aspects, permeability and selectivity. Another factor is the chemical stability. So as we know, the membranes are exposed to chemical agent, are exposed to chemical oxidation, and if the material are degrading so fast, the replacement become more frequent and more costly. Another factor is let's say the fouling resistance of the membrane. We have biofouling, we have organic accumulation on surface, we have scaling. So a well-designed membranes shall mitigate the effect of this issue, and let's say new advanced treatment surface, new advanced treatment on surface shall be developed. Traditionally, the membranes are in polyamide film composite material, and now the research is exploring more cost-effective materials like graphene oxide, like carbon structure, carbon nanotube, also these biomimetic membranes that are mimicking the natural water channeling, that are improving also the efficiency. And last but not the least, the energy efficiency. Developing a new material that are increasing the permeability without, let's say, without affect the retention rate, the rejection rate, can help to reduce the energy cost, bringing to a more sustainable and more accessible membrane application.
Thank you very much, Rosario. That's true. Even this balance between permeability and selectivity, I think that is going to grow the importance of that now that we are jumping into this brine collection world that is going to make the potable water the residual product of the desalination plant. Yeah. No? At the end of the day, it's going to be mineral factories, the new desalination plants. We have with us John. John, you are working in TACA. TACA is, developing hugely the new materials coming to the membranes, even making investment worldwide. I would like to know from your point of view, John, which are the main challenges at the time of developing these new materials?
Yep. So initially I thought about the traditional polymeric outer membrane as a discussion topic, but I believe most of you are familiar with this traditional membrane and its characteristics and its limitation. So as you are aware, this traditional polymeric membrane is working based on diffusion theory and limited by the theory itself. But what if there are new material which is working on different principle? Then the whole characteristic and challenges could be completely different. So far, a few names of new material have been in the market, like graphene and the MOF. MOF stands for the metal organic framework. So I understand these two materials may be working on sieving mechanism or side exclusion. Then the driving pressure and energy consumption and fouling characteristics could be completely different. So if we start from the graphene, so as you are aware, the graphene is a 2D material in a honeycomb structure. And mostly in a single layer of carbon atoms, either in the shape of piece of paper or on a tube. So it was discovered in 2004. Then later Nobel Prize was awarded in 2010. So 2 decades has been elapsed since the discovery. So why we are not seeing the graphene membrane in the desalination? So I think the limitation is coming from the manufacturing process itself. So there are 2 to 3 different production methods. One is the exfoliation, which is the mechanical way of producing graphene. And at the time of the discovery of this graphene in 2004, this adhesive tape was utilized to isolate single layer of graphene from the graphite. But the problem is the size itself. At the time, the size of the graphene was like a 10 nanometer. But if you think about traditional outer membrane with the size of 8 inch, so one element typically has around 40 square meter of the area. So between 40 square meter and 10 nanometer, so it is too small. And there is another type of production method, which is chemical vapor decomposition. It's like a thermal deposition method. And there is the medium, like a copper plate, and it will be heated, and 2 different gases like methane and hydrogen will be introduced. Then these 2 gases will be deposited on the heated surface, and it will be forming a graphene. But the challenge is coming how it can be recovered from the heated surface. That is not easy. So in terms of the graphene, we have a challenge in the manufacturing process itself. Then another potential new material for the desalination would be MOF. It may work like a molecular sieve. or snap button. I mean, if you visualize the snap button, we are pressurizing one part of the button into the other. So in this way, we can separate a specific molecule. But as the name stands for, it consists of metal ions and organic ligand. So organic ligand is binding different type of the metal ion. And the organic material could be weak, and the durability could be a challenge. But because the working principle of these two materials are similar to the sieving mechanism or size exclusion, the driving pressure and accordingly the energy consumption could be significantly lower if these are commercialized.
Okay, let's hope that we manage to reduce the energy consumption once it's commercialized, and as well, we manage to improve the recovery of these potential new graphene membranes. Thank you very much. So, as we said before, it's very important to protect the membranes of the desalination plant as a core part of the desalination plant. In this regard, the Cartier filters used to play a significant role. In this regard, Anthony, what can Entegris offer to us? What are the last developments speaking about Cartier filters, new materials, new design conditions? What can you tell us?
I found very interesting your comments on the graphene and this type of materials. So it's interesting because in the company, we make specialty materials for different industries, and we are using, for instance, carbon nanotube that we inject in our polymers so that we control better the diffusion of airborne molecular contaminants through the raw material of the polymer, and we make sure that it does not diffuse and outgas more. So I found it very interesting to see that transfer of experience between those industries. We can, when you look at membranes used in filters, in polymer filters, right? Not reverse osmosis. You can play on, when you think about R&D, you can play on different aspects. You can play on the polymer you're using, the nature of the polymer. And you have plenty of polymers that you can use as a chemist. We are using extensively like PTFE membranes in very harsh chemistries. We are using polysulfones in other chemistries. You can use as well UPE. It's a polyethylene, but it's an ultra low molecular weight polyethylene that brings lots of added values. When you think about water treatment and desalination, so far we have not found better than polypropylene. Polypropylene is very inert, because when you talk about filtering contamination, it's very important to look at the retention rating, but you need to make sure that you do not add contamination, because when we manufacture our polypropylene filters, we need to make sure that it is manufactured in a very clean and safe environment, so that when you put your filter in the water, you will not bring bad contaminants in there. So polypropylene is really the champion. It's inert, it's cost effective, it's stable. When you think about PTFE, then you have a big problem in terms of sustainability, the PFAS, how you make the recircularity of PTFE, that's a big problem. Polypropylene is easy. So I think desalination has a very great advantage. You can make good filters with polypropylene. Outside the material you can use, then you need to work on the structure of the membrane. And when you talk about structure of the membrane, you need to talk about density of the polypropylene you're going to use. So here you have research and developments made in the gradient of density you make in the membrane itself, with the benefits I described previously in terms of less pressure drop. And that's very important and very unique. When you talk about those cartridge elements but the cartridge filtration, you need to have the GRP housing. In the way you operate your GRP and you manufacture, you need to reduce the weakness in the structure. That's another element of development. Make sure when you operate your GRP, it is well in one piece done with no weakness at the end of the structure. But we can go further, but I'm not sure when and if the industry needs that. We can go down to nanometers in terms of particle retention. Here, in that industry, we talk about micrometers. We can go down to nanometers. We're very advanced. We can remove as well ions, metals. We can remove organics. So we have a full palette of opportunities that can be tested. But so far, the structure of the polymer is the more important aspect that we are developing for that industry, and the way you manage GRP.
Okay, thank you very much, pretty clear. And now we are going to go to a more commercial question, starting from Rosario, and maybe you can as well add something. It's about the membrane markets. The number of companies able to provide membranes for reverse osmosis, I would say today is 3.
Yeah, maybe if there are
2.
some manufacturer here representative, maybe they will not be happy about my answer. But 2 of the major challenges in reverse osmosis industry today are the high cost of the membranes and the limited number of manufacturers that are dominating the market. Inevitably, this is leading to keep the cost high and to slow down the innovation. So how can we address this? We have to invest in advanced material. As Mr. Antoine said before, there are a lot of material like carbon nanotube, like hybrid polymers that are more cost effective. The cost of production are relatively lower, and maybe so they can maintain and even improve the performances of the membrane. Another aspect is so the investment on startup companies, encouraging more players to enter in the market, and we need open source design. We have to invest in collaboration, research collaboration. I think the most important topic is to extend the lifetime of the membranes, reducing let's say the needs of replacement. We are in 2025, so we have all the tools and all the capabilities to invest in regenerating technology to create a circular economy that can reduce the cost for the users and can reduce also the impact, the environmental impact. So we need to establish a policy, and we need to establish policy for a price, let's say, I want to say price leveling, but price transparency is better. Maybe giving some benefits to those companies that are investing in innovation, some tax benefits. And so finally, we need also to mandate, for example, an open compliance, an open standard compliance to permit the easily interchangeability between different manufacturers.
Yeah. Yeah, but I think that's very true. But as well, we need to think, it's something interesting what is happening in the membrane sector. It's a market that is becoming more and more mature, and as long it's getting more mature, we are having less suppliers. While, for example, to send rocket to the space, now we have Elon Musk, no, Amazon, NASA, India as well. So, no, why? I mean, and you have critical asset in your hands. So imagine that you are in the government side and you say, look, I'm about to have all my critical assets supplying water in the hands of 2 suppliers worldwide. If one fails,
this is the limitation of research developing. So I think government has to invest in collaborating research with university, with so
as well as all the
with the
stakeholders.
startup.
John, I don't know if you as a government entity want to say something.
Yeah.
You have this feeling that the desalination market is going that direction in the membrane sector to just to be in hands of 2 companies in worldwide for the supply of membrane.
Right. But I believe there are companies who are interested in this major market, Middle East, and trying to enter into the market. And so I think they are welcome, and they will contribute to the competition among the manufacturers. And in the end, the benefit could be shared all the stakeholders, like including me and you, and all the citizens in the Middle East. Yeah.
Absolutely.
Yep.
And John, let's think in a desalination plant in 15 years' time.
Right.
Imagine that we have to foresee and to describe how a desalination, what will be different from the desalination plants that we are building today?
Well, so you're talking about 15 years' time, and personally, it's a long time. But if we think about the technology development and the market itself, I don't think we may have completely new membrane. Maybe we may continuously using maybe improved, but the conventional polymeric membrane. And as we just discussed, and we are seeing more number of membrane OEM entering into the market. And we have seen a tremendous effort, not only from the industry side, but also from the academic side. And which resulted in the level of the technology which we are enjoying at the moment. I believe this will be continued. And in the overall, I could anticipate the cost in overall would be reduced. I cannot tell the number, but that I can see. And because we are assuming the conventional membranes are continued to be utilized, and then in terms of the salt rejection, we already exceeded 99%. So it could not be 100%, so it should be somewhere in between 99 to 100%. So it may remain there, but I understand some of the membrane OEMs are launching new membrane, which decrease the energy consumption with increased production. So the efficiency improvement in terms of the energy consumption and more amount of water production would be continued. So we may see improved efficiency in next 15 years' time. And also I understand each membrane OEMs are doing the research to optimize these membrane spacer to minimize the fouling in the membrane. So I'd like to see improved membrane with less amount of fouling in 15 years' time. So these are my anticipation.
Okay, thank you very much. I'm sure that we are going to reduce the fouling. We are going to improve the efficiency. It's very important what Rosario said to put circular economy as well into the picture. And I'm going to take now my private part and say, I think that maybe it's time to slower the discussion about the price. Today we are producing 1,000 liters of water by $0.50 or 7 cents. So I don't think that the problem now for the water is the price, but nevertheless, maybe it's time to start speaking about the quality of the water, that don't forget that we put inside our body between 1.5 liters up to 2 liters in daily basis, and I'm missing a lot. We are speaking about other food products that we put into your body, everybody is worried about. Maybe it's time to reduce the discussion about the price and to speak more about something that we are taking in our mouth. In this regard, we speak about innovation. Innovation as well is about culture, it's about the DNA. What can you tell us about this experience you have in the culture of how important it is to have a proper culture of innovation inside a company?
That's a very interesting question. I think there are different facets in that, and you need to look at different aspects for maybe very obvious to not very obvious. I think when you talk about an organization, right? An organization and a company, I believe the culture of innovation starts with the top leaders in your company and the leadership in the company. I think that's super important. And if I have to take the example of Entegris, our CTO comes from IBM, our VP of R&D comes from IBM. They spent 15, 20 years in semiconductors, in data centers, where the speed of innovation is just a necessity to stay alive. So it starts with the leaders. Another aspect, I think, and we can argue about it, we like companies, experts in their segment, in their, like, we are a membrane company, so, oh, you're the expert of membrane, so we trust you, so innovation is good. What is very important, maybe counterintuitive, is to expand your portfolio outside your core. For instance, filtration, go to particle monitoring. Because when you extend your portfolio, then you can leverage on both. So what does it mean? It means that you need to have as well a strong willingness from your management to look at merger and acquisition. Always have the market intelligence, your fingers on the pulse, and don't look only at your core business. Look at others. And I think that's the third element, is the industries. From semiconductors, we learn speed of innovation and purity. We transfer that to water treatment. From water treatment, we've learned the obsession of energy saving. We transfer that to life sciences. In life sciences, we've learned about the importance of safety and quality, because that's a human being. And we transfer that to all the rest. So it's really having access to the different industries, learn and try to transfer to others. I think that's part of the culture of innovation. And if I may, the last bullet point, very obvious, not done, enough, collaboration, collaboration, collaboration. I know that confidentiality is important, but you can find a way to collaborate together without compromising confidentiality. You need to find the right people, companies and personalities. People open-minded, ready to take risks. And it's not well spread out in all industries. So I think that's a part of innovation, I think.
I concur with you 200%. This permeability and ability to share how you are moving forward, and to have visibility in different sectors is very important. Don't forget that KH7, that is one of the most powerful cleaners today, is coming from the R&D department of an industrial company searching for a product to clean their engines. So, and they shift from engines to cleaning products. So thank you very much, I concur with you. So now I don't know if we have time for questions. No? So we finish here. We just thank the panelists. It was a really interesting panel. Thank you very much.
Thank you very much.
Thank you very
It was a
much.
pleasure.
Thank you very much.